Imagine playing a game of chess where your computer has to think through millions of possible moves every single second. Sounds powerful, but also painfully slow, right? Now, here's the real pain point. What if most of those calculations are completely useless? What if your AI is wasting time analyzing moves it will never choose? This is exactly the problem early game-playing AIs faced. And the solution? Alpha-Beta Pruning, a smart optimization that allows AI to think faster, smarter, and deeper without checking every possibility. In this video, we'll break down Alpha-Beta Pruning in artificial intelligence, step by step, in a way that actually makes sense. Welcome back to the AI Explorer, where we decode intelligence. Alpha-Beta Pruning is an optimization technique used with the Minimax algorithm, mainly in game-playing AI like chess, tic-tac-toe, and checkers. Instead of evaluating every possible move, it cuts off branches of the decision tree that won't affect the final decision. Think of it as, why explore bad options when we already know something better exists? Let's explore this through 5 key concepts. To understand alpha-beta pruning, we must first understand the problem it solves. The Minimax algorithm works by assuming both players play optimally, maximizing the AI's score, minimizing the opponent's score, but here's the issue. Minimax explores every possible move. The number of game states grows exponentially. This causes massive computation delays. For example, a chess game can have over 35 trillion possible positions. Even modern computers struggle with that scale. So, while Minimax is correct, it's often too slow to be practical. This is where alpha-beta pruning steps in. Alpha-beta pruning is a search optimization technique that reduces the number of nodes evaluated by Minimax. It introduces 2 values. Alpha, best value the maximizing player can guarantee. Beta arrow, best value the minimizing player can guarantee. The rule is simple but powerful. If alpha becomes greater than or equal to beta, we stop searching that branch. Why? Because that branch can't influence the final decision. In simple terms, alpha equals I already found something good. Beta equals I already found something bad. If they clash, stop exploring. That's pruning. Let's visualize this. Imagine a game tree, max player at the top, min player next. Leaf nodes have scores. As the algorithm explores, max updates alpha, min updates beta. If alpha greater than or equal to beta, remaining siblings are ignored. Example, max finds a move with value 8. Min already has a move limiting max to 5. No need to explore further. Max won't choose worse options. That entire branch is pruned. Important point, pruning does not change the final answer. It only removes unnecessary calculations. So the AI plays just as well, but much faster. Let's talk efficiency. Without alpha-beta pruning, time complexity, O of b to the power of db is equal to branching factor. D is equal to depth of tree. With alpha-beta pruning best case, big O of b to the d halves. That's a huge performance boost. What does this mean practically? Deeper searches, faster decisions, stronger AI opponents. This is why modern chess engines and game AIs rely heavily on alpha-beta pruning combined with heuristics. Alpha-beta pruning isn't just theory. It's used in chess engines, Stockfish AlphaZero, combined with ML, game AI, strategy and board games, decision-making systems, adversarial search problems, any scenario where the 2 agents compete. Decisions are sequential. Outcomes depend on optimal play. Alpha-beta pruning helps AI make intelligent decisions efficiently. Let's recap. Minimax is powerful but slow. Alpha-beta pruning removes unnecessary branches. It uses alpha and beta values to prune decisions. Result? Same accuracy, massive speed improvement. This is one of the core foundations of intelligent decision-making in AI. If this video helped you understand alpha-beta pruning in artificial intelligence, Give it a like, share it with fellow AI learners, and subscribe to the AI Explorer. We break down complex AI concepts into ideas that actually make sense. Until next time, keep exploring intelligence